So Sunspot 2924 has grown larger. Likelihood of solar flares has gone up. Coronal mass ejection watch remains in effect. We expect to see more plasma in the sort of earthly side of the sun. Let's blast through a ton of data. And thanks for joining us, all of you stargazers out there. So this sunspot here, this is 2924, and it has grown a bit since yesterday once again. So that's 2 days of rather steady growth. A great example of a sunspot spontaneously showing up, just kind of forming. This one went all the way around the sun. That's now named 2925. Here are the magnetic fields. And you can see the consolidation of these trailing umbrae here. Those are North Pole polarity. The leading one south. Welcome to cycle 25. Let's look at the rest of the magnetic fields before we move on. Some organization happening in the north also. I don't think any sunspots up there. Here's ionized helium. All this imagery from the SDO, the Solar Dynamics Observatory. Radio flux is, I think, only up to 86 yet. So radio flux has yet to come up. We can expect to see it rise quite a bit in the coming day or two. In fact, today you can expect to see it rise. Showing up as only 84 here on the Space Weather Enthusiast dashboard readout. No space weather storms forecasted at the moment. We do have Venus on the LASCO C3. We'll show you that momentarily. What's been going on as far as earthquakes? Well, let's take a look. Vanuatu saw a deep quake. We reported a bunch of deep quakes on yesterday's space weather video. Solomon Islands saw a deep quake. None of those larger than a 5.2. Some activity in California, it looks like a 4.8 near Deep Springs. A 5.7 in the Southern Pacific was, I think that might have been the largest of the past 24, or was this one? I think that 5.7 was the largest quake of the past 24. Also a 4.6 off the coast of Petrolia, California, it looks like. And what else? Papua New Guinea saw a 5.0. Excuse me. And yeah, pretty calm as far as earthquakes in the past 24. Check it out. It's Kilauea's Halema Uma'u thermal camera. That's the overlook crater. You can see the crater rim here. The thermal camera at the Halema Uma'u lava lake. Let's see what else is erupting here. Shivaluch. On the Kamchatka Peninsula, exploding. Flight level 130 as a result of Shivaluch's activity. Subanosejima flight level 060. That's a 6,000 foot above sea level ash plume. The top of the ash plume, 6,000 feet above sea level, and altitude of 060. Fuego, flight level 150. As Fuego explodes, that's located in Guatemala. And a little farther south in Colombia, 21,000 foot ash plume as Nevado de Ruiz explodes. Sangay and Revenador. Revenador's dispersed its ash. So a little bit of a cease of eruption there at Revenador. Sangay still producing a 20,000 foot ash plume as it explodes in Ecuador. Also intermittent emissions from Sabancaya. A reminder to not pole vault the caldera, but do visit our website. Welcome to the Neo Renaissance. You can find our links there. That's the main purpose. All kinds of links on the website. Check us out all over social media as well. Share with your friends and foes. We need your assistance to get the content onto screens, obviously. And one of the ways you can support the channel is by becoming a member of the Smash team. Here's a sneak peek. Gold and silver members get preferred treatment when they log in. Continuing on, And thanks to our gold and silver level SMASH team members. GOES magnetometers here over the past 3 days. There's the data from those. Nothing too exciting happening there. Earth remains in a South Pole current sheet. Easily seen here on the top view ecliptic plane field plot showing up in red. Here's a line of sight view. We're actually expecting a North Pole current sheet to show up here once again. Don't be surprised to see a North Pole current sheet spontaneously show up, as nothing seems to be random in the universe. Yes. Next line of sight coronal hole plot. South Pole oriented coronal holes there in the earthly zone. Not really transequatorial ones. The ones that are setting in the west are. Those North Pole coronal holes are transequatorial. If you want to look more about coronal holes, you can go to solon.info. There's a sort of a link there to all of the most recent coronal holes going back many years, actually. Here's the 193 angstroms from the SDO. And those sunspots trailing that South Pole oriented coronal hole. There's actually a bit of coronal hole in between those two sunspots as well. Speaking of sunspots, let's take a closer look at that. There's 1700 angstroms. You can see the consolidation of that trailing umbra there. So likelihood of solar flares goes up as a result of all of this. Sunspot 2924 has been growing for a solid 2 days here, having spontaneously showed up. Here's 94 angstroms. The previous one was 335, if you're wondering. And you'll see the flare probability a little bit higher here as a result of this. NOAA and NASA would agree on this. X-ray flux here rising a little bit. No significant flares, not even a C-class intensification here for over 3 days. No proton spikes, no major flares, no relativistic particles. Earth's magnetosphere is pretty weak at the moment. Not a lot of induced current as a result of things like solar wind parameters, which are slow and low. So less than 4 protons per cubic centimeter for the solar wind density, only 350 kilometers a second for the solar wind speed. It's a slow, diffuse solar wind. It's brought the KP index down to 0 for about 18 hours there. 18 hours consecutively. KP 0, geomagnetic calm conditions, very calm conditions, to the point where there's very low pressure in Earth's magnetosphere. This is a model of it for the past 4 hours. Yes, we were recording the video around 1300 Universal Time. Next, ground magnetic perturbations. This is the Earth's B field, as expressed in this flat plane here, a two-dimensional view of the Earth's magnetic moment from the ground. Geospace delta B changes to Earth's B field, modeled in nanotesla magnetic flux density. Calm conditions as far as that goes. And here's what's going on in the solar system. Let's forward this 7 days. Approaching another full moon there in a week. It'll be a gibbous waxing on the 13th. The 7-day solar system forecast. And you may see Mars rising ahead of the sun if you're up before dawn. If you've got a low enough horizon, you might see Mars. By the way, Venus has recently stopped being the evening star as it's gotten too close to the sun. And let's take a look at our coronal hole view. Not our coronal hole view, our coronal mass ejection view. My mistake. The view from Lagrange point 1 and Lagrange point 5, the location of the LASCO C3 and stereo A at Lagrange 5, LASCO C3 at Lagrange 1. There's our custom diagram once again. And that's why the evening star, the third brightest object in the sky, is visible there on the LASCO C3. That one's known as Venus. And if you're a new viewer, when we forecast coronal mass ejections, we're doing it for this side of the sun, because the Earth is off in this direction. We don't do them on this side. We do them on this side. And we have reduced the coronal mass ejection to a watch. Coronal mass ejection watch now in effect, not a warning. And don't be surprised to see it instantly go back to a warning. We may have to make another video about it today. It could happen, so stay tuned for that. This is another cosmology segment. We'll integrate this one once again to the daily space weather video. I'm going to show you some oddities here. We're now picking a random number between 1 and 76, which is 50, which coincides with an object here on the Black Hole Candidates page, which you can link to from the main page at the Neil Gehrels Swift Observatory, the Burst Alert Telescope. Anyway, today's featured X-ray source is entry number 50 on the Black Holes page, 50 of 76, which is XTE J1755-324, a low-mass X-ray binary / quote, black hole candidate, end quote. Here are its X-ray outputs. You can see it's a cyclical X-ray source here on the, that's the 16-year chart. And here on the 30-day chart, it looks like it's been X-ray quiet until the past week. So that's always interesting. Let's take a look at this thing visually. So this is the DSS colored. You can see some features very close to that crosshair. Possibly not a coincidence. Let's take a look at it in infrared. Whoops, pardon my scroll. There we go. And it's quite a hot part of space there. There's actually a cold zone there. That reddish zone looks like it's colder. And this is multi-spectra here on the 2 mass. That's 1.23, 1.66, and 2.16 nanometers. When we look at it in ultraviolet here on the Galix, see, it is not really any signal, more of just an ambient background signal there in ultraviolet frequencies. And we've brought it back to infrared here. We'll zoom way, way, way in to show you the location of the Milky Way galactic plane in relation to this object. You can see it's kind of on the outskirts, not really in such a dusty disk area, but still quite a busy region of space here. That's the 2 mass imagery for XTE J1755-324, entry number 50 on the Black Hole Candidates page at the Neil Gehrels Transients. And we'll close things out with the third brightest object once again being featured here in the cosmology segment. My personal favorite planet, well, besides Earth, I guess. There is Venus in its phased state. As it gets too close to the horizon where it starts to get obscured by the sun. It's the astronomy picture of the day today at apod.nasa.gov. And that's today's cosmology segment. We kept it short. Showed you just one cosmic object. It's all related to heliophysics, folks. It's called the Standard Concordance Model of Stellar Evolution. Next, looking at charging hazards here around planet Earth. To see none. Surface charging is typically caused by electrons. And we just see nominal levels here. A little on the high side. The 17 went into warning a little bit yesterday. Not really enough to be concerned with. And NOAA forecasting a flattening here of the electron flux. Once again, like yesterday's forecast, no argument from me there. We can only forecast upticks and downticks in the electron flux at certain times based on the physics. Next, the total electron content forecast. This is the electron content in the plasmasphere in the inner Van Allen belt, the area of space in between your GPS satellite and your handset. So some minor anomalies here around the Southern Ocean and Antarctica. Otherwise, looking pretty organized there with the electron flux. I'll let it play through a second time. It'll show you where GPS errors are most likely. Some anomalous high electron flux there over North America. And some around the Drake Passage. The Drake Passage, one of the weirdest parts of the planet. I need to go visit. It's on my bucket list. Yeah, the Drake Passage, folks. Next, the ionosphere. The F layer is located at about 300 kilometers of altitude. There is the ionogram, courtesy Australian Government Bureau Meteorology. We hope you meteorologists are not wearing a mask at the moment. So that's your ionogram showing you vibrational frequency. We do see some anomalies here, once again, around the Drake Passage. Also, lots of low-frequency anomalies in the southern hemisphere in general. This anomalygram shows you anomaly in megahertz from the 30-day median. And yeah, low-frequency anomalies, some high-frequency anomalies in southern South America as well. So some swings there of the vibrational frequency going on in the bridge between Earth and space. Make sure you check out Tamitha Scove's 4-hour video about the inner workings of the ionosphere, her mini-course. Anyway, there's a latest image. That's 12:15 Universal Time. And you can see some anomalies there around Central Africa, the Central Atlantic of the high-frequency variety. And let's do bonus features. Bonus feature the first is the GO 16 SUVI. You're looking at ionized helium. It's a heliogram. Check out the crown prominence. A little bit of prominence happening down here. Another feature associated with solar maximum. So anyway, this sunspot has actually grown since we did show prep. You can see additional umbrae forming there, increasing the likelihood of solar flares. That one, 2925 there, not quite so active. Here are the magnetic fields. That's a beta gamma class sunspot now, 2924. 2924 is barely beta class. So anyway, the likelihood of solar flares has gone up as a result of that just in the past hour or so. Possibly have to make another video about that. Coronal mass ejection watch. Thanks for tuning in, and may that solar wind be at your back. Opinions expressed in this video not necessarily the opinions of Smash News Network, least busted name in news.